So Brian is advised by Amber, and I'll let you take it from there, Brian.
Good evening. Can everyone hear me?
Yes.
Perfect. My name is Brian Thackston. My capstone project is entitled Implementation of Lean Principles into Root Cause and Corrective Analysis Processes, and my advisor was Professor Riegel. Next slide, please. And we can skip through the table of contents. There's a lot to cover. So as an introduction, I work as a manufacturing analyst at a large defense contracting firm. What a manufacturing analyst means, essentially it's a micro project manager. I'm responsible for following hardware through manufacturing cells, making sure that it completes on time and ahead of schedule. Over the past decade, there's been more accountability placed on military spending, and as a result, more pressure on firms like mine to provide greater value, to build hardware cheaper, to build it at an accelerated rate, to build better performing hardware, and essentially just to drive the value to the customer, who, in our case, is ordinarily the warfighter. And as a result of the pressure that we receive from the government, a lot of firms, and mine included, are pushing towards incorporation of lean initiatives. One of the opportunities that I saw at the beginning of this process in a discussion with my leadership was essentially developing a process or a system to determine root cause of quality issues and action plans in a more proactive manner as opposed to reactive. We needed to quickly assign root cause and corrective analysis to mitigate quality issues. And really the key takeaway on this project is that we wanted to understand the data and take action quickly. Essentially, we collected a lot of data in terms of our product. Quality issues, we just weren't doing all that much with it. And we can go to the next slide. So a little bit of background. When hardware moves through our manufacturing cell and it is deemed non-compliant for either a test failure, physical defect, documentation error, some sort of issue that needs to be corrected, a quality notification or a QN is written against the work order. In our system, it's SAP. These quality notifications are the vehicle for my organization to order replacement components if rework's needed, to reroute units for additional steps to repair, to fix paperwork issues, whatever it is. And my team's very efficient at that, and the turnaround is about 4 to 5 days in terms of getting it back into WIP flow. What we wanted to address with this is that when the quality notification is generated, it also captures data about what's going wrong in our factory. And that data is oftentimes not effectively reviewed until weeks or months down the line. And with that sort of delta between defect emergence and review, you potentially expose a lot of hardware to what could be a repetitive issue. So it's not necessarily we're looking to catch like one-off issues, but when half of your units going through test fail one specific type, you want to be able to catch that and address it prior to that exposure being hundreds of units. So what we found was that quality notifications were not being created and addressed in real time, and that there wasn't a system in place to effectively identify trends based on the quality notification data. Down the road, after quality defect trends had emerged, root cause corrective analysis efforts would be generated manually by the engineering team to explain what happened to executive leadership, and to kind of say, this is what we think we should do in the future to keep it from happening. But being so far, down the line, it doesn't really do much to mitigate the problem at its source. Next slide, please. For my literature review, I reviewed the book Lean Thinking, Banish Waste and Create Wealth in Your Corporation by Womack and Jones. It's kind of an older book. I think it was released in 1995, but it breaks down lean thinking into essentially 5 categories or aspects that need to be addressed. And it was one of the key pieces of reading for me to understand what my organization was trying to implement in terms of defining the value for the customer, identifying all the steps in the value stream and challenging wasted or non-value added steps, uh, trying to push manufacturing process changes in a way that make product flow through smoothly, pulling product between steps where continuous flow is possible, and the idea of working towards continuous improvement where the number of steps, time, and information needed to serve the customer consistently decreases. In addition to that, and because a lot of what I do is kind of incorporated in my day-to-day job in value stream mapping and trying to identify sort of non-value added operations and waste, I reviewed Learning to See by Rother and Shook as well, and that kind of helped me organize some of the data in this. As far as a background on what we decided to do with this project, I wanted to create a database that would roll all of the QN data from SAP daily in a way that it could be created quickly. And then my initial goal was to provide that in a dashboard, such as Tableau or something centrally programmed, so that that data could be used by manufacturing management to allocate engineering resources appropriately based on kind of emerging trends for what defects we were seeing. I met with manufacturing management, quality engineering, the manufacturing engineering team to discuss how QN data is managed and evaluated. And in the course of those discussions, I was made aware of an active but kind of underutilized database called the Trace system. It pulls a ton of different operational data from SAP daily, but it's basically used as a backup system. It was developed a few years ago and scrapped in favor of using Tableau for a different purpose. But it rolled all the QN data and essentially stored it. So kind of understanding that this database existed and we just weren't using it, I kind of dug in and found who the administrator was, who the programmer was, and I met with them in mid-January to discuss the database capabilities and kind of my goals for what I wanted this project to be, that I wanted it to tangibly feed back data to manufacturing in a way that they could make more actionable decisions. The result of that meeting was that we could reformat the database with some minor tweaks to allow the assignment of failure mode identifiers, which I call FMIDs. And essentially what that was going to allow us to do was bucket the QNs so that we could essentially roll together like QNs and determine the scope of issues, which could then drive engineering efforts. Programming took a few days, and within a few days I was given access to bucket QNs, and I selected program and hardware to use as a pilot lot. Next slide, please. So the data. From January 19th to April 6th, I reviewed and categorized 1,348 QNs. This is a manual process. It took about 2 hours a day because it was value added to my program. Fortunately, it was funded. There's no standardized format to the QNs in our system. So all the text has to be reviewed manually. And you're really kind of at the mercy of who wrote the QN as to what data you're going to get out of it. Sometimes it's very specific in terms of like the frequency at which it fails on which channel and that sort of thing. And sometimes it's literally just an X and you have to just figure out what it failed from, you know, the cosmos. The QNs that I reviewed, about 70% of them were generated upon test failure. About 24 of them were inspection failure, and the remaining 6 were manufacturing review. And with the volume that we had with this build, it really kind of highlighted the need for a system that categorizes quality notifications and paraders the data for actionable review. Because we had this existing database, we were able to kind of expand the scope, and I'll go into that in just a little bit. But if we can go to the next slide, you can take a look at the actual data broken down by FMIDs. So as you can see here, we have a breakout of everything that was QN'd for this one specific pilot build over the course of that. The main detractors were electrical failure, unidentified. That's essentially a troubleshoot queue. They'd fail. We wouldn't necessarily know what was wrong with them, or they would have lids on them, and they wouldn't be able to identify what it was in. So that went into a troubleshoot queue. Hardware damaged and hardware defective both came out of the test. FOD was generally out of inspection. So it was a lot of different issues, but this data allowed us to categorize kind of what we wanted to go push engineering to address right off the bat. And we can, I guess, go to the next slide for that. So for the model and kind of how the project evolved, initially I wanted to create a dashboard that was going to provide the data to manufacturing and let them make the decision on what they wanted to address and what they didn't. But because we had the database in place and because it had capabilities beyond what I can program, we were able to actually create a system that you can manage root cause and corrective analysis efforts through. During the categorization process, you can actually assign QNs to any sort of existing root cause corrective analysis effort that's in the system. And what this does, it allows you to not only bucket the QNs by failure mode to generate RCCAs, but to continuously feed new data into the RCCA. So that when you close that effort, you can say that you've actioned it and completed it. You get an overall view of the number of units, the time affected, and the cost through either rework and scrap or through schedule shift as a result of this issue. The RCCA system kind of consolidates all of the efforts made because some of the data is managed in SAP, some of it's in PowerPoints, some of it's in Excel files, some of it's kept on servers or jump drives, and being able to pull all of that data together into one place to manage it, it's a really powerful thing and something that we're really looking forward to and that we're excited about turning over to our engineering team. So far, we have generated and managed 3 root cause corrective analysis efforts through the system. The first one that we did is actually the bottom one, the coding defect. There are 169 units affected by that. We generated the RCCA manually, pushed engineering to go look at it. They added some inspection steps to the coding issue, and I guess bookended the issue so that we knew what stereo ranges we were dealing with. That's been actioned and completed. The results of that saw an increase at final inspection yield of 23%. The next RCCA was our component defect. I'm sorry, can you go back? The component defect is still in progress. We have identified the source of the failed components. They are third party, but we're implementing source inspection on specific components. And we're still waiting on potential spec adjustment for marginal failures. And the final one, the physical damage, which is the highest detractor, is also the highest cost to fix. So that's currently in the cost benefit analysis with the program, waiting to find out whether the defect of physical damage is high enough to warrant the purchase of new tooling. Go on. So as far as results and recommendations, we did generate 3 RCCAs and reviewed as discussed. Our we're currently in the process, and it's been slowed down somewhat by the coronavirus, to migrating the QN categorization to the engineering team. We did consult with the engineering team when we created the FMIDs, so we've allowed their input to make sure that when we do turn over the system to them, that the categories make sense for what they're doing. It should also be noted that there is a level of granularity to this data that isn't captured by the initial FMID process. We actually have two levels of FMID. So within electrical defect or hardware defective, you can have hardware that fails for S parameters or phase or voltage or current or attenuation or like any number of different things. I didn't categorize the second FMID because essentially I just don't have the technical background to look at the data and to be able to tell what that is. But the engineering team does, and we're hoping to roll that out to them in the coming weeks as we get back to work and we can get into like in-person work sessions with the engineering team. As far as recommendations, we'd really like to standardize the QN formatting. That's a much bigger task than it necessarily sounds like when you consider the size of our organization. But standardizing the QN formatting will lead to one, quicker review and categorization when done manually, but also opens the door to potentially automating the QN categorization in the future. And we're also working towards establishing metrics for the FMIDs to where when it hits a certain threshold, if it's over the course of 30 days and you get X percentage of your fallouts categorized as one particular FMID, the system will be able to automatically generate root cause corrective analysis and ping engineering to go take a look at it. It isn't necessarily real time, it's as quick as you can evaluate it. So I had to QN or categorize the QNs every day. But if it's turned over to the engineering team, they would be working consistently on it, and it could potentially push to identify the trends through the RCCA process much quicker than we're doing now, and potentially identify trends before products even off the line yet. The last recommendation I have would be to incorporate cost data and planned attrition to help rank the RCCA projects. Currently, the system ranks the RCCAs by highest percentage detractor, but there are high volume, low cost detractors in that data. So what the system considers to be the most important RCCA is not necessarily the most cost effective to the program or to the manufacturing cell. Incorporating cost data, planned attrition, and MRP will, while it'll take some time to do, will allow the system a little bit more flexibility in terms of evaluating which RCCAs are going to provide the best value per dollar or value per hour in terms of financial benefit to the stakeholders involved. We can go on. In conclusion, we reformatted an existing database to provide a quicker rollout for usable data in manufacturing and engineering. We did expand the scope of the project to where previously we were collecting and assembling data in a way that was going to be passively displayed. And now we're essentially pushing the RCCAs in to try and influence engineering efforts directly. We're aiming for a full-scale rollout in October of 2020. That's pending engineering review and some updates we have to make to the system. Next slide. For the future expansions, we already discussed some of this, standardizing the QN formatting and incorporating the cost and MRP data. So we'll go ahead and move on. And as far as references, my books are referenced, the team that I got to lead for this project, and Professor Riegel. That's all I got. Thank you.
Okay, great. We do have a question for Brian in the chat, so I'm going to go ahead and read that. You indicated that 1,350 QNs, that there were numerous descriptions that were no more than an X for failure. Given the number of incomplete evaluations, for lack of another term, how confident are you that the QNs are being placed in the correct silo, i.e. your chart? And is there a plus or minus factor in your evaluation of the QNs?
Any QN that didn't provide the data needed for me to address it as an FMID. I met with Josh Kurtz, who's program engineer in the references and acknowledgements. We went and actually looked at the test data, and he provided the FMID recommendation. So I am confident 1348 are categorized in a similar fashion to how subject matter experts who are going to be taking over this process would categorize them.
Great. Other questions for Brian? All right. Thank you, Brian.
Thank you.
And we